When I first unboxed the Beelink ME Mini, my immediate reaction was, is this an Apple product? Whether Beelink was going for that clean minimalist aesthetic or not, it absolutely gives off strong Mac Studio vibes. But that's where the comparison ends, because once you slide off the outer shell, things get a whole lot more interesting. Inside, there are 6 M.2 slots ready to house full-size 2280 NVMe SSDs. This isn't just a pretty face, it's one of the most impressively engineered compact NAS devices I've ever reviewed. Let's dive in.
It's the money.
Hey guys, CJ with Elevated Systems, and today we're checking out the ME Mini from Beelink. Now, I've reviewed several mini PCs from Beelink over the years, and overall, I've been pretty impressed with what they've delivered. But this is the first mini NAS device I've seen from them, and it's a totally different beast. It's somewhat similar to the GMK Tech Nookbox G9 NAS I looked at a couple of months ago. Both are compact multi-M.2 NAS systems powered by Intel's N150 chip, but I think Beelink has executed the concept much better here. Of course, I can already hear the hardcore home lab crowd saying they made too many compromises, and yeah, I get it, but I'm not here to convince you to buy anything. What I'm going to do is walk you through everything this little NAS has to offer, its specs, features, capability, and performance, and hopefully by the end, you'll have all the info you need to decide if the ME Mini makes sense for you. To do that properly, we'll need to install a full-featured NAS operating system. So in this video, I'll also guide you through the installation and setup of TrueNAS Community Edition on the ME Mini, step by step. Now, let's take a look at the hardware. The Beelink ME Mini is a compact cube measuring just 99 millimeters on each side. It's powered by Intel's Twin Lake N150 processor, a 4-core, 4-thread chip with a 6-watt base power and a max boost clock of 3.6 gigahertz. The unit I tested came with 12 gigabytes of LPDDR5 memory running at 4800 megahertz, and a 2 terabyte Crucial P3 Plus NVMe SSD was already installed. The system boots from 64 gigabytes of onboard eMMC 5.1 storage. The ME Mini includes 6 standard M.2 2280 slots. The slot occupied by the pre-installed SSD is a PCIe Gen 3x2 interface, while the remaining 5 are Gen 3x1. Each by one slot has a theoretical max bandwidth of around 1 gigabyte per second, and in my test using Team Group's MP33 drives, I measured sequential read-write speeds of 850 and 890 megabytes per second. You can populate all 6 slots with up to 4 terabyte SSDs, allowing for a total capacity of 24 terabytes. There's no onboard RAID controller, so any redundancy or performance configurations will need to be handled by software. On the back of the unit, you'll find dual 2.5 gigabit LAN ports using Intel's i26V NICs, one HDMI 2.0 port that supports 4K at 60 Hz, and a USB 2.0 port with always-on power. The front panel includes a 10 gigabit per second USB 3.2 Gen 2 Type A port and a 10 gigabit Type C port. Wireless connectivity is handled by an Intel AX101 card providing Wi-Fi 6 and Bluetooth 5.2. As for power, the ME Mini features an internal 45-watt power supply and uses a standard AC power cable. No external brick or barrel jack required. At the time of filming, the ME Mini is available with the 2 terabyte Crucial SSD for $329 or just $209 without the SSD. As for the build quality and materials, internally, the ME Mini is built around a large aluminum heatsink. I mean, large relative to the size of the unit itself. It spans nearly the entire interior and serves as the primary cooling solution for both the Intel N150 processor and the SSDs. The SSDs mount upside down directly against the heatsink, which provides active thermal dissipation across all 6 drives. That active cooling is handled by a single top-mounted fan positioned at the center of the chassis. It pulls air in from the vents on the bottom and sides of the enclosure and exhausts it through the top. The airflow design is simple and quiet, and I'll go over how effective it is when we get to the thermal performance section. Since all the actual cooling hardware is internal, the outer shell doesn't need to contribute thermally. It's made of a matte plastic and feels sturdy, and it does the job. And while it leans heavily into that Apple-like aesthetic, the internal layout is clearly purposefully built for practical use, especially when it comes to serviceability and thermal management, way more flexible and functional than anything out of Cupertino. Setting up the ME Mini is straightforward. On the bottom of the device, you'll find 4 rubber inserts. Popping these out gives you access to 4 screws. Once removed, the outer shell slides off easily, revealing the 6 M.2 SSD slots. Installing SSDs is simple. Peel the plastic off the thermal pad, remove the SSD retention screw, insert the drive. Note again that it installs upside down to make contact with the internal aluminum heatsink, and then secure it back in place. For testing, I installed 5 1TB Team Group MP33 Gen 3 NVMe SSDs, the same drives I used for the GMK Tech Nookbox NAS review. With the drives installed, I slid the shell back on and connected a keyboard, mouse, display, and Ethernet cable to get ready for the OS install. Now, the ME Mini does ship with Windows 11 pre-installed, but unfortunately, the setup process on my unit kept freezing at the same point, and I wasn't able to get the OS fully operational. That's a bit disappointing because this system could potentially serve as a dual-purpose box, something low power for basic productivity and web-based tasks, while also functioning as a RAID-style NAS using Windows storage spaces. I reached out to Beelink about this issue. If and when I hear back, I'll post their response in a pinned comment below. So if you're looking to run Windows and set up storage spaces, that should still be an option if and when the issue is patched. And I've got a tutorial for that setup you can check out here. That said, for today's video, I'll be wiping the Windows install and replacing it with TrueNAS Community Edition, formerly known as TrueNAS Scale. So let's take a look at the installation and setup process. To get started with TrueNAS, you'll need a USB thumb drive with at least 8 GB of capacity and access to a second computer. First, head over to the TrueNAS website and download the TrueNAS Community Edition ISO. You'll also need a tool to write that ISO to your USB flash in a bootable format. For this, I'm using Beelink Etcher. It's a cross-platform and easy to use. If you don't already have Etcher, download and install it, then launch the app. Click Flash from File, select the TrueNAS ISO, then click Select Target and choose your USB flash drive. Once that's done, click Flash to begin the process. When it finishes, eject the USB stick and plug it into the ME Mini. Next, power on the ME Mini and spam the delete key to enter the UEFI. Here you'll need to disable CSM support under Advanced Settings and disable Secure Boot under Security. If you want, you can also change the boot priority to the USB drive here, or you can enter the boot menu by spamming the F7 key on power up. Once you reboot, the system should boot directly into the TrueNAS installer. When you land on the initial screen, just hit enter to begin the installation. The next step is selecting the target storage device for the TrueNAS install. One advantage the ME Mini has over the GMK Nookbox G9 is that its onboard eMMC storage is properly exposed as a block device, which means you can install TrueNAS directly to the 64 GB eMMC module. This is convenient because it keeps all 6 M.2 SSD slots available for storage pools. However, there are some considerations. The system uses an HP DV4064 eMMC 5.1 module, which does support basic trim and wear leveling. eMMC storage typically has lower endurance compared to NVMe SSDs. For instance, MLC-based eMMC devices generally support around 3,000 program erase cycles. With minimal write activity and proper offloading of apps and datasets to the NVMe pool, this eMMC storage should realistically last 5 to 10 years, likely longer for systems used primarily as storage servers. But if you'd rather avoid using the eMMC entirely, you can choose to install TrueNAS on one of the NVMe drives. Just highlight the drive you want to use, press the spacebar to select it, and hit enter to continue. Keep in mind, this will completely erase the selected disk. Next, you'll be prompted to create an admin account. Select the default option, enter and confirm your password. Then enter again to begin the installation. The process will take a few minutes, and once it says it's successful, hit enter, which will bring you back to the initial install menu. This time select Reboot System. Hit enter, remove the thumb drive, and you'll see a stream of status messages as it runs, and eventually you'll arrive at this screen, which means installation was indeed successful and your TrueNAS server is running. At this point, make a note of the web interface IP address displayed. Mine, for example, is 10.0.0.140. Now, this is the IP address my router assigned via DHCP, and in my case, it's always going to be the same. My router reserves IPs per device, so for me, this is essentially a static IP address. But if your router doesn't behave the same way and might reassign a different IP later, you'll want to log into your router settings and either allocate the IP for the ME Mini or manually assign a static IP. If you're not sure how to do that, don't worry. Someone on this fine platform we call YouTube has almost definitely made a tutorial for your specific router. At this point, the physical setup is done. Leave the ME Mini powered on and connected to your local network, and you can go ahead and disconnect the peripherals. From here on out, we'll be setting up and managing the server headlessly through the web interface. So from another computer connected to the same local network as your new TrueNAS server, open your favorite web browser and type in the IP address shown at the end of the installation. You should be greeted by your very own TrueNAS login screen. The username is TrueNAS_admin, and the password is the one you created during the installation. From here, you'll land in the TrueNAS dashboard. There are a lot of options for customizing things, but you can explore those on your own. Today, we just want to get a simple storage server up and running. First thing I'll do is check for updates. TrueNAS is based on Debian Linux, which is well known for its stability and unofficially follows the "if it ain't broke, don't fix it" philosophy. So while you will get important security and bug fixes, TrueNAS won't bombard your system with constant, potentially breaking updates. That said, this version, TrueNAS 25.04.1, ships with kernel 6.12, which is modern enough to fully support all the hardware here, including the Intel N150 and its integrated media engine. Once the system is updating, the next thing we'll do is create a user. In the left-hand menu, click Credentials, then Users, then click Add. Here we'll set up a username and password. The default settings are fine. Just make sure the SMB user box is checked at the bottom, then click Save. Now we have a user account that can access our SMB share, so let's create some. Click Storage in the left side menu and then click Disks in the upper right. Here we can see all the drives installed in the system, starting with the boot eMMC, the 5 1TB Team Group SSDs, and the 2TB Crucial drive. Also make note of the 2 small partitions on the boot device, because when we go back and click Create Pool, we'll get a warning about 2 drives with non-unique serial numbers. That's just those 2 MMC partitions, so you can safely ignore that. To create the pool, first give it a name, then click Next. Now comes probably the most complex decision you'll need to make, choosing a layout. Now, I'm not going to dive into every VDEV or RAID configuration. You can find full videos breaking those down, but I will say this: if you want to max out performance on this system, use 6 SSDs of equal capacity and go with a mirrored layout of 3 VDEVs, each with 2 disks. That means 2 mirrored drives make 1 VDEV, and 3 of those VDEVs create the full Z pool. If one drive in any of the mirror fails, you're fine, but if both drives in a single VDEV fail, you lose the whole pool. The trade-off here is speed versus capacity. The setup gives you the best read and write speeds, but it cuts your usable storage in half. If you'd rather maximize storage capacity and are okay sacrificing some performance, go with a RAID Z1 layout, which is what I'm doing here. I'll select all 5 of the 1TB drives. Since RAID Z1 requires a minimum of 3 drives, I can only create a single VDEV with these 5. If I had 6, I could split them into 2 VDEVs. Now, If I check the treat disk size as minimum, I could also include the 2 terabyte Crucial SSD, but it would be treated as a 1 terabyte drive, matching the smallest capacity in the pool. If you want to be specific about which drives go where, you can click manual disk selection, add a VDEV, and manually drag your preferred drives into the VDEV. But in this case, I'm using all 5 team group drives, so I'll just save it and click save and go to review. You can see the total usable capacity comes out just under 4 terabytes with 1 drive's worth of capacity reserved for parity. That means if a single disk fails, no data is lost and the pool can be rebuilt using the parity data spread across the other 4 drives. When I click create pool, I'll get a warning that all data on the drives will be erased. This is essentially the same as formatting a drive. I get asked a lot if you can preserve the data on a drive when adding it to a new pool, and the answer is no. If there's anything you want to keep, move it off the drive first, then copy it back after the pool is created. Pool creation is a destructive process. Now it's time to set up a dataset. Open the dataset options, select the archive pool and click add dataset. Give it a name, let's say footage, and set the preset to SMB for cross-platform access. Make sure create SMB share is checked so that TrueNAS will automatically create the share and start the SMB service. After saving, the new dataset will show up in the shares menu, ready for network access. Back in the dataset menu, I'll select my new dataset, click edit under the permissions tab, and click add item. In the user dropdown, I'll select the CJ user I created earlier. I'll make sure the modify permission is selected and click save access control list. Now, if I open the file explorer on the Windows system I'm using, under network, I can see the TrueNAS server. Once I enter the user credentials, I can see the footage SMB share I just created, ready to upload files to. At this point, you've got a fully functional network attached storage server. Of course, there are still a few things you'll want to do, like setting up backups for your TrueNAS configuration, enabling periodic snapshots, configuring smart tests and email alerts, disabling unused services, maybe even installing some apps. I'm not covering all that today, but this is YouTube, plenty of tutorials out there for whatever you need. For my testing, I did install and configure Jellyfin just to help evaluate the performance of the ME Mini. So let's get into it. Now, you might assume the biggest bottleneck here would be the M.2 SSDs running over single PCIe lanes, but that's not actually the case at all. Even on Gen 3x1 lanes, the SSD reached close to 900 megabytes per second in sequential read-write tests. The real bottleneck is the network interface. With only a 2.5 gigabit Ethernet connection, your theoretical max transfer speed is around 312 megabytes per second, and realistically, it'll be lower. Yes, you could theoretically aggregate both internet ports for increased bandwidth, but that's not really an entry-level task, and this is an entry-level NAS. And realistically, most users, if they even have a wired home network, are still working with standard gigabit, which caps out at 125 megabytes per second. On top of that, using RAID Z1 introduces overhead that can reduce write speeds by as much as 60% for sequential workloads. So what kind of real-world performance does this NAS deliver? To find out, I ran both synthetic benchmarks and practical tests. For the benchmark, I used my Mac Studio, which has a lightning-fast SSD and a 10 gigabit Ethernet connection, just to eliminate any bottlenecks on the client side. Using the Blackmagic disk speed test, I saw sequential read and write speeds of 233 megabytes per second. That's only about 25% below the theoretical max for the 2.5 gigabit Ethernet, which is actually impressive, especially considering the RAID Z1 configuration. For real-world testing, I transferred just under 12 gigabytes of mixed data over 1,300 files and folders, including a mix of small random files and large sequential ones from the Mac Studio to the Beelink. The transfer took exactly 2 minutes, averaging 100 megabytes per second. Copying the same 12 gigabytes back to the Mac took just over a minute with an average speed of about 177 megabytes a second. That's solid performance, especially considering the number of tiny 1 kilobyte files in the mix. Power efficiency is another strong point. The NAS draws just 10 watts in idle and peaks around 14 watts while streaming 4K video from Jellyfin and simultaneously handling read-write activity across the pool and network. That tight power envelope paired with the ME Mini's active cooling system kept the CPU temperatures below 60 degrees Celsius during testing, with SSD temps peaking just under 54 degrees Celsius. And the noise level is virtually non-existent. Even under sustained loads, the fans stay whisper quiet. I literally have to put my ear right up against the unit to hear it at all. Now, again, I'm not here to sell you this device. My goal was to show you what it's capable of, demonstrate how simple it can be to set up your own home storage server, and put its performance to the test. Hopefully I did all that well enough for you to decide whether or not the Beelink ME Mini fits your needs. That said, I was generally impressed with this little NAS. It's well designed, it looks great, and it performs better than I expected for the price. If you're considering picking one up, I'd recommend going with the $200 version that doesn't include the crucial SSD. You're not really saving any money by getting the bundle, and skipping it gives you more flexibility when it comes to filling out all 6 SSD slots with your own drives. And honestly, $200 is a shockingly good price for what you're getting here, especially considering the build quality, expandability, and how quiet and efficient it is. So if you found this video helpful, make sure to give it a thumbs up. If you want to see more in-depth hands-on reviews like this, along with tutorials and custom builds, consider subscribing to the channel. Got questions, feedback, or your own experience with the ME Mini? Drop it in the comments below. I'd love to hear what you think. Thanks for watching, and I'll see you in the next one.